How's it going, everybody? In this episode, we're working on the undercarriage.
Yeah, my plan right now is to take the sprockets off, or what's left of them, and then hopefully swap on the old, or the ones from the other machine, so we have complete sprockets and the undercarriage doesn't have to be touched again. And so the plan is right now to pull this track frame, get it outside, and pull that sprocket off. I don't remember how the other one, it's been so long, I can't remember how easy or difficult it was to get the other one off. So I'm hoping I can get this apart without too much hassle and without wrecking a lot of gaskets. I'm gonna get the front of the machine jacked up, get some blocking under it, pull this track frame, and then start working that sprocket. So. Now, I should just be able to there's some bolts holding that cap on. That extends down to the track frame. And then these bolts here, they go along the end of this bearing holder. That should be everything holding the track frame on. And then the front, it's just these, the mainspring there, which is loose now, or has no weight on it. That just bears down on the track there. So there's nothing connecting the front of the track to the machine. So I'll just go ahead and get all those bolts removed, and hopefully I can slide that track frame out. These are all loose because we already had this off. Alright, so that cap is free. There's a couple dowel pins that I think it's hung up on. And it's got 4 inches to fall, so I don't want to get my feet anywhere near it. I have to get this this part free of the mainspring, so I got to slide the whole track frame over. Which isn't bad on concrete. Concrete on steel slides pretty easy. I can stay there for now. The next thing is, I think, is to take these bolts out, get this cap off. Before I do that, I want to put a pan under here. These final drives are still full of oil, and I think I want to replace it anyway, so I don't care what it goes into, but I just want to make sure it doesn't get on the floor. Apparently it's not that tight. I'll keep that in mind. So a lot of grease packed in here, which I don't remember in the other one. Don't remember that being in there. So it looks like this dust shield is what's keeping me on, I think. So I just got to pull out some of these 9/16 bolts. Surprisingly, all these undercarriage parts seem to, you know, they don't put up as much of a fight as you'd expect being on the bottom of a bulldozer for however long. You know, it seems pretty rough conditions down here. But still, you can get at these things, and even with the heads being as corroded as they are, I'm thankful I can still get a wrench on there. Of course, when we put it back together, we're just gonna gob all the bolts up with grease, which is probably what helped them come apart in the first place. Well, that one could probably stay on. Just knocks all some of this front off on the floor. All right. Kind of remembering some of this now. There's a pinch bolt down here that helps to keep this bearing holder is what they call this. It helps to keep that tight. And then there's this nut, which is used one to hold the hold everything in, and it's giant. It's this castellated thing back here. It's a very, very large nut, and there's these teeth which you get on it with a spanner wrench, and there's this one holder at the top, you know, just a keeper on there with the bolt. So I'll pull that off. Now with all that off or removed. You can get a spanner on this and hopefully use this nut as a press, and you can pull this bearing holder off of its seat. I remember on the other machine there's a key in here that was sheared and held this up so bad that I had to get a 50-ton press and pull the holder off that way. Hopefully this will go a little smoother. I'll just be able to use the spanner. Oh boy. Let me see if I can get a pipe on this and pull a little harder. It's gonna be a tough one. That's almost 200 pounds on the end of that. I think I remember maybe using an air hammer along with the tool being supported by the jack. So I'm going to try that. I can push this thing outside. Nothing for now, I guess. All right. Got it to budge. You can see it's no longer lining up. So it's a little bit of movement. Okay, slowly going. Now, of course, I can only put as much force on this bar as the machine weighs on this side, because at some point you just start picking the machine up. So, can switch to the other bar. I think what's happening is as I get to the top of stroke, there's two jaws that come with this, and one's wider. I think this one will be nicer because it'll be able to stay on just that tooth without getting hung up on anything. I think I'm getting stuck on something as I go. So, let's try this. Looks like I do my hand now. That's good. Ooh. Starting to see some oil come out. So I'm gonna try to catch it. I think we're off the fit here, and now it's just a matter of running this thread all the way off. Easier said than done. So that's the bearing holder. I think what I was doing at the end there is accidentally tightening this nut on, and I was just jamming it up against here. So I'll have to go back through and, back this off, which is going to be a pain, but that's okay. You can see in there is the cone for one of the, this outer bearing, where that's the race, this is the cone for the bearing. This bearing should come off with the sprocket. You can see this is a dead axle. So this is stationary to the machine the whole time. And you can see the axle is actually a hollow tube. The live axle is a hollow tube that the sprockets gets pressed onto. I think I'm going to leave this cone on for now, because I don't have a good way of getting behind it, other than using the nut to draw it off. But I have to go ahead, get this lock washer unbent, which it looks like it's pinned over there, get that undone, and hopefully I can still apply enough torque on this to get this nut undone. It might require using a punch, but yep, looks like that's the only one that's pinned over. Go ahead and get that set up. Okay, I'm gonna just knock this right now. Not moving. So I'll do the same thing. Spanner tool in the jack, get some tension on it, and bang with a hammer. Let's see, I think I'll put the main clutch in gear. Put it in first. Alright, so I got the maybe if I use the brakes. Nice thing the brake works. I put it in gear, and I was trying to use the engine to brake against, but the other sprocket is free. So I was just going through the differential. So it was just spinning. I don't know if I get the brake on. Yeah, I can get enough on there. Get the move. Hopefully I'm going the right direction. This isn't left-handed or something. Good news is, it's definitely a right-handed nut. I now have a little bit of an air gap. You can see, maybe right there you can see that washer just moving now, which before was not, which was a pain. It's definitely right-handed. It's extremely fine thread. Kind of figuring out my workflow. There's not enough lugs on that to easily go from one to the next. I have to adjust the tool, and I don't want to have to spin the sprocket by taking the brake off because that's kind of a pain to do. But what it should be happening now is I'll be pushing that bearing cone off with the nut. And hopefully at some point it just kind of gets easy. I don't have to use this jack anymore. For now it's still pretty tight, it feels. No way in hell. After all this, I think I got a 1/16 of an inch of movement on that thing. This is going to be a long process. I think typically you'd be able to start the machine, use the engine to run this thing off. That would probably do it in a heartbeat. Although this engine has a big hole in the side, and I'm assuming a rod sticking into the side of the block. So, no starting this one. Another donut. It's going. Oh, it's going. Holy Christ. You know what I could probably do instead? No, I can't do that. I was gonna say I could jam the tool against the ground, take the brake off, take it out of gear, maybe even pull the steering clutch, and then put the bar on the sprockets. I'll try that. If I get the steering clutch pulled, that might take enough out of here. Hopefully the clutch isn't locked up. Because there might be enough residual in the whole drive line that would make that not worth doing. But we'll try it. Okay, steering clutch is pulled. I'll put the nut tool on this side. Get that jammed against there. I think that bearing just came free. Wowee. Wowee. Ha! As soon as I change my tune. Oh, no, it's there again. No, wait. Wait. Yeah, I got this backwards. That's what happened. I just loosened it up. Well, that's the way I need it. Nice thing to know is that the steering clutch is free on this side. Is that right? What am I doing right now? I'm tightening. Yeah. Need to be going this way. Why can't I figure this out? This way. Oh, there. Jesus Christ, Frank. I feel like going in the Barbarian just with half the amount of strength. Pair of gloves. You know what I'm gonna do? Get this track from outside. If it wasn't in my way, I'd feel a little better. Also, something to do. officially outside. Okay. Back to this hog. I'm tired. Only about 100 more reps. We're getting there. Stair climber. Using all the machines at the gym. I could do deadlifts over there, doing stair climber over here. Boy, pretty soon I'm gonna look like Arnold Schwarzenegger. Conan the Barbarian. It's only on it by like 1/4 of an inch. Got it. Got it. Holy Christ almighty. That's kind of warm. Okay, now, after all that, need to thread the net back on. All right, now the nut's back on. The idea here is that you leave enough gap so that when you get your puller up on here, you can pull. The socket or sprocket will release off its taper, and as soon as it moves at all, it'll be free. But because you're applying like 50 or so tons to get the sprocket off, you want something there to catch it. Because if this thing flies off, you know, with all that energy, it'll just shoot the puller right at your knees. So you put the nut back on to kind of catch it. Next job is to get the puller on and come up with something that I can press on this with. See if I can get that happening. Okay, I got the puller up there. It's pretty much centered, I feel like. Kind of just got it cribbed up with some 6x6s, or 2x6s. Let's see.
Tom's putting a bunch of pressure in the puller now. And then the trick is, once you got it tensioned up, you hit it with a sledgehammer a few times to shock it, to try to break it free.
It's a lot of force. Yeah, let's just go, I guess. Something to hide behind. There it goes. Whew, woo-wee. So there's that shaft. It's in there. Right here, I don't know if you can see, is this surface is a seal, so it's a wiper, or not a wipe, but it's a, you know, a facial type of seal where it's just a really flat surface. And there's two of them on the sprocket. So this one goes the outside. There's a matching one, and this is the one on the inside where we just saw. And those just ride against each other. They're a real fine, you know, polished, lapped surface. And that's what keeps your final dry fluid in. And those are really expensive. So we want to be able to clean those up. We have a whole set from the other machine that didn't seem like it was leaking. This one seems like it's good. It doesn't look like it's leaking. So as long as we keep those clean, we should be able to throw it back together. So now, I don't know. It's what time is it? 5:40. Might have enough time to get this side done and then call it a day. And then at some point, I can get the sprocket off the machine outside. Hopefully, you know, I don't know. Hopefully, maybe just a hand. Another pair of hands would make that nicer. was gonna say if it's warm out, but I don't think it's gonna get warm anytime soon, so. Oh, alright, let's see if I can get this side off. Boy. Boy.
Alright, so it's a week later. Tom got the other sprocket on that other machine off camera. So here you can see how he set up the puller.
The far side, the other side of this machine, we took off a couple of years ago, maybe a year ago. Last week, I did the two remnants of sprockets that are on the other machine inside. And now, this weekend, I'm going to pull this one, so I'll be able to take footage of this. I've already got it down to the point where I've got my nut back on, with a little bit of a gap there. I've got a big piece of steel, this used to be an old plane bearing, that I'm going to use to bridge over the dead axle. So there's the dead axle in the center, and there's the live axle there, you can see floats on top of that. This will bridge over that, and I got a big plate, will go on there. The puller will hook over, you'll see, and then we'll just press it off. This, I believe, is a 50-ton puller, and it gets just about to its capacity, what I feel, using the power pack. Pretty sure we're using almost all 50 tons to get it off, so hopefully this doesn't prove to be too much of an issue. But I'll go ahead and struggle getting this thing together. Start by hooking this up over the top there. These more or less in position. I'll try to slide this plate in. Hopefully kind of friction and gravity will hold everything. That's the idea. There we go. So now we're close. Get a jaws seated, and then I'll pump the jack a little bit and try to center that up a little better.
That ain't good. Let's get a closer look. Tom didn't notice right away, so he set it back up and put it back under tension. But now he noticed.
Oh, that's not good. Did not pop. We already pulled up against the nut there. Well, let's back it off a little bit. Let's start to sag. That's not a good sign. You really want these to be a tough pull. In fact, I have a little bit of video on my phone of the one releasing, and you'll see it was a little bit more violent. So we'll have to inspect these splines really well if we're going to reuse this sprocket. That's not good. Let everything fall away. Yeah, that's loose. That's a bummer. It's not what I wanted to see at all. Alright. That's a problem. Now, we'll see. Let's clean up the sprocket good and see what happened. I'm not sure if this is going to show up on video very well. Jesus Christ. See if this comes up on photo. You can see this Now, of course, this isn't cleaned up yet. I don't know if I have a rag in my pocket. No. Try to get some of that cleaned. You can see the irregularity in that surface, almost like it's burnelling. What that likely is the sprocket was not pressed on with the correct amount of force. So it was likely loose on here and it was shimmying back and forth. It even appears like these are a bit sharper than the ones on the machine inside. I'll have to take a look at that. What's more important is if those splines, if those are messed up, what we're gonna have to do is torch the sprocket ring off of this and weld it onto the other machine, you know, the other hub, which is just gonna be a pain. Not impossible, but not what I really wanted to do. But I'll take you inside and we'll try to compare. You can see, if I can catch it right in here, that's not anything I can wipe away with my finger. That's you know, metal that's got pulled away or pushed in or moved around. I'll clean that up once we get inside, but I'll go show you the one inside. Alright, we're back inside now. And here's, I got a rag over this. This machine had a lot more grease and everything in here. But you can see there's corrosion, but it's also just, I don't know how to explain the difference. You can see there's machining marks in here, but they're not worn down like the other one was. They're, you know, this is from manufacturing those waves. It's not pushed around like the other one. And I can tell just visually the land on the top of the gear tooth is wider out here than it was on the other one. The other one, this was almost sharp. So let's get the sprocket in here and take a closer look at it. Taking a look at this sprocket, I decided it's gonna make sense to go ahead and cut it off, this hub, and stick it on one of the hubs that I pulled off that machine, because like I was showing you outside, there was some wear on the splines. It's gonna be hard to get on camera. You can kind of see that ridge, or that it's like a step. You can hear the pick go over it. That's where it's been taken out of the spline. If I try to put that back on, you know, this machine here, it's under a tarp now. If I try putting it on, you know, a fresh axle, you know, with good geometry, it'll likely end up just, you know, wallowing it out over time. This one, bring the light over. This one, it doesn't have anything like that step. You know, it's a you know, there's no, it's smooth. The whole facet on these splines is smooth to the bottom, which makes me feel a lot more comfortable using this. It also means I can just leave the seals right in here. I'm not gonna have to bother swapping these. You have to make sure these sliding seals are lapped, and then over time they'll wear into each other on the machine, so you want to keep track of them as a pair. So if I was going to use that sprocket as is, I'd have to take this seal out, put it in there, and then that way it goes back on the one that's in the machine. But I'm going to go ahead and get this chopped off. I'm just going to use an angle grinder with a cutoff wheel. I think a lot of guys use oxy, acetylene, or like a arc gouging set or something like that. I'm just going to do it with a cutoff wheel. I see why guys burn these off. This is some tough stuff. Makes sense. It's probably some abrasion resistant alloy, whatever. And I don't know what they use. I thought it was just like a 7018 or something that they use to weld these on with, but maybe it's something they might use some other type of more durable filler material. I'm gonna go get the torch out and see how much acetylene I have, and hopefully it's enough to get this off. Well, I got my acetylene out here, my oxy stuff. Just got my acetylene stuff. I got myself up on horses instead of the garbage can that was under there, so in case, you know, it was almost guaranteed I was gonna light that on fire. I turned on the acetylene and the tank's practically dead, so I'm not gonna use oxy. I'm gonna go back to grinding discs and just hope that I can get through it with the pack that I have. Yeah, it's kind of a lateral move. There's a sprocket ring. That probably would have been about twice as fast with oxy, and I could have beveled the edges. Now I'm gonna have to go back through with another grinder and 45 everything, so I got a nice V to weld into. And I'm gonna have to read up and see what kind of filler to use. My plan was just to MIG it, but I might end up stick welding it if it calls for, you know, some special filler. I think this is my hottest welder. That one down there might be 200 and some 250 amps. Yeah, that one's 225. This one's 215. If I go like a dual shield on the MIG, I think that's probably the best penetration I'm gonna get. But that bottom welder, if I max that out with a like a 7018 or something, whatever I think they call for, we'll see. I don't know. Another thing, people might be wondering, if you're gonna go through all the effort of chopping this thing off, why wouldn't you just buy a new sprocket ring and weld it on one of those? Part of the reason is that this sprocket is worn in to the tracks that we have. So that sprocket is worn in to those tracks, right? You can see. Those pins have already been rotated once. Somebody went through this undercarriage before we bought that machine, and they changed the sprocket. You can tell those have already been welded on once, not factory. The pins have already been rotated, so there's some amount of wear in those tracks that I want to match with the sprockets that came off of them. Don't mind this thing. This is another project. We got a lot of projects going around here, like that car and this truck and some other stuff going on. There's some wear in here that we want to preserve. The worn sprockets with the matching worn track, so that everything's kind of together. I don't know how a better way to put that. The other thing is you can buy these rings. If you buy them from Cat, they're outrageous. And if you buy some offshore ones, I'm not convinced that the ones you buy from offshore are going to be the same alloy, be the same, abrasion resistant that these are. These aren't perfect, of course, but yeah, that's the reasoning there.
All right, this video is getting long, so I'm going to go ahead and wrap this one here. Next time we'll get that sprocket welded on, then get the hubs pressed back onto the machine, install the undercarriage, and then hopefully pretty soon we're finally going to be able to see this thing run. And I am looking forward to that. So I hope you enjoyed this video. Thanks for watching, and we'll see you next time.